Hello everyone, myself Vamshi Krishna. I am from Civil Engineering Department. I am working as Assistant Professor in St. Peter's Engineering College. Today I am going to discuss about the topic admixtures from concrete technology subject. Okay. Before going to the actual topic, I want to discuss few points regarding concrete. So what is concrete actually? Concrete is a mixture of fine aggregate plus coarse aggregate plus water and most important part is cement. Okay, so what is the concept of admixture? Why we need to add something to this mixture? Are we facing any problems? Yes. So we need to list out the problems first, and we need to know the properties of concrete. Okay, and then we can know the importance of the admixture. Okay, so why we are adding some agent to the mixture? The mixture is mixture of fine aggregate, coarse aggregate, water and cement. Okay, it is easily we can understand that something adding to the mixture. Here we are dealing with this. Okay, so what are the problems and what are the properties of concrete? And the engineers have developed an innovative way, that is admixture. So innovative way towards admixture. Okay, first we need to discuss about the concrete properties: strength, durability, setting time, and workability. Okay, so if you are knowing the difference or definitions of everything, so we can conclude the use of the admixtures here. Okay, these are the properties. We need to know each and every property clearly about each topic. Okay, so what is strength of concrete? How do we define the strength of concrete? Okay, strength of concrete is nothing but strength. What is strength actually? The strength can be defined as the resistance to the failure, how much it can bear by the external loads, how much you are bearing before failing is known as the strength. That itself, here also the same concept with the concrete, how much you are able to bear, how much you are taking the load with respect to failure is known as strength. So we can write the definition as resistance to failure. How much concrete is resisting? How much concrete is resisting before failing? That is, how much concrete can take loads before failing is determined. I mean, is defined as strength of concrete. Okay. What is durability then? Durability. Durability, I mean, we may get confused. Why? Because in the word itself, there is a word related to duration. So it is not related to duration. First thing I want to conclude here itself. It is not related to duration. Durability is something different from the duration of concrete. Okay. Durability is, it is also resistance to chemical attack, abrasion, weathering properties, and other environmental conditions. So here we can understand that durability is resistance to chemical attack. So our concrete should be safe, or it should not fail for the chemical attack. It should be resistance towards abrasion. It should be resistance to weathering. Weathering is nothing but the removal of the layer, the expulsion of layer from the surface is known as, due to any physical process or chemical process or biological process from the atmosphere. It can happen from anywhere. So due to weathering, concrete must not be deteriorated. Properties, weathering properties, and other environmental conditions. Environmental conditions means the concrete structure which we have built, it may be exposed under mild rain, or else moderate rain, or else severe rain, very severe rain, or else it can be buried under severe chemical properties of the soil also. So it can be buried in that situation also. So durability is nothing but it should have resistance to that chemical attacks, abrasion, weathering properties, and other environmental conditions. Okay. So what is setting time? What is setting time? Setting time can be divided into two types: initial setting time and final setting time. Initial setting time. Initial setting time is setting. In the word itself, we can understand that concrete is going to set. It means it is going to become hard. So it is converting its state from the plastic state to rigid state. So it is going to harden. So the initial setting time is nothing but time at which concrete is losing its plasticity. So the time at which concrete is losing its plasticity is known as initial setting time and final setting time. What is final setting time? The time harden. It means the time, how much time it is taking concrete from its rigidity to hardened state. is known as final setting time. Okay, why we need to know this initial setting time and final setting time? Do we require to know about these properties? Yes. So the answer is simple, yes. Why we need to know the initial setting time, final setting time? If we know the initial setting time and final setting time only, we are able to know the amount of preparation time, how much time is available. When you start mixing the proportions of concrete, you need to know the time, uh, till what time I can go to my site, or else till what time I can mix the sample, or else till what time I can transport on the road. So how much far is my travel time? So based on that we can calculate the uh, plan to my site. Okay, should we mix in the site itself, or else can I mix somewhere, I mean in my manufacturing place only, where the environmental conditions or everything are in controlled. Okay, so we need to know the initial setting time and final setting time for that reason. Okay, so then what is workability? Workability is nothing but ease of working with concrete. Okay, so how you are able to work with concrete? Workability is nothing but the ease of working with concrete. So when you are mixing, how is the type, how is the nature, is it in the plastic state or it is losing its plasticity, it's going to rigid state. So we need to know that. So how the working nature with the concrete is during the process, during mixing, during placing, during transporting, during compacting, we need to know the working nature with concrete. So it is required. The workability is the most important parameter in the entire concrete technology. So based on workability only, the strength of concrete is defined. So workability must be controlled. Okay, so here water cement ratio, I want to include a new term here, water cement ratio. What is water cement ratio? Weight of water by weight of cement. Okay, for the amount of mix of cement, how much water is required to get a perfect mix for the concrete? Based on we have a code for the concrete technology, we can take recommendations from the IS code, IS 456 2000. This is the code which is dealing with concrete technology and RCC. Code gives recommendation how much you are going to mix, how much you are going to, how much, what proportions you need to mix, and what amount of water cement ratio, at what ratio you need to add the amount of water based on the cement requirement, and to achieve the strength. Ultimate thing is we need to get the two parameters, strength and durability, and then safety and economy. Four parameters are the most important thing in concrete technology. So these IS code will recommend what to, how much amount you need to add water cement ratio based on different environmental conditions. Is it mild or moderate, severe, very severe, extreme, like that? Okay, so now I can explain different properties: strength, durability, setting time, workability. Now I can use these terms clearly. Okay, when can I achieve strength and durability? When concrete is in hardened state. Okay, when can I deal with these properties? When concrete is fresh. That is, these properties are fresh properties of concrete. When concrete is readily mixed, we need to deal with these two properties, and these two properties are when concrete is in hardened state. That is, concrete is losing its plasticity, it has achieved its hardened state, and there we are going to talk about strength and durability. Durability is nothing but based on durability only different environmental conditions. They are mild, moderate, severe, very severe, and extreme. Okay, we have learnt about different properties of concrete. We know the concrete mixture, what are the ingredients are forming to make concrete, that is fine aggregate, coarse aggregate, water and cement. Okay, and what are the different properties of concrete, that is strength, durability, setting time and workability. Now here comes the major part. So what are the problems? What are the problems we are facing? Problems in concrete that had lead to the development of admixtures. Why we are going to admixtures? So before going to this admixtures, we need to know the problems in concrete. Okay, if I want to use the concrete in hot weather conditions, so in hot weather conditions, the concrete may easily set easily, the water present in the concrete mixture, it gets evaporated and it is going to hardened state at the early time. So that is the major, that is one of the problem. So in hot weather conditions, concrete sets easily. Concrete sets easily. This I cannot change. This problem I cannot change. Why? Because I am not changing the ingredients, I am using the same ingredients: coarse aggregate, fine aggregate, water and cement. So based on its own properties, initial setting time I cannot change. So in hot weather conditions, the accelerating thing is temperature. If temperature is increased, water gets evaporated and it is going to its hardened state easily. So in hot weather conditions, concrete is setting easily. That is one problem. But I don't want to make concrete to set easily. So I want that modification. So I cannot do. So I am going to admixture. What type of admixture, which type of admixture we need to do, we will get to know after knowing some more problems. Okay. In cold weather conditions, these are conditions based on the temperature. If temperature is very high, we can conclude that the hot weather conditions are prevailing. If the temperature is very low and I need to use the concrete, so the conditions are cold weather conditions. Okay. In cold weather conditions, temperature is very low. Here concrete does not set easily. Concrete sets slowly. So I want to modify this property. How can I modify this property? That is the problem. So I am going to admixtures. What admixture is doing, we'll discuss later. Okay. Here concrete is setting slowly, so I want to modify this property. That is also one of the problem. Okay. One more problem. Workability. Okay. During transportation or during in any circumstances, in any problem, if the concrete is getting hard based on the after completion of initial setting time or final setting time, I cannot stop the process. But if I want to work with concrete to little more, some more time, I mean there is a time to work with concrete, so I cannot add just like that some water to it and use the concrete. So if you are adding additional water to the mixture, the problem here is if you are adding water to the concrete after construction of the structure, the water which is occupying the volume, so due to the temperature conditions, due to the climatic conditions, water gets evaporated easily, and there itself on the surface itself we can, the cracks are visible. So it is also the major problem in concretes. So workability, if we are using for more workability, we require workability more, so we are using water more. That is not the solution. If you are using water more, cracks are also developed easily. On the surface itself the cracks are visible. So the problem, due to the crack, when cracks are visible on the concrete, freshly constructed place, we can easily say that they have mixed additional amount of water other than the specified requirements suggested by the IRC, I mean IS code. So workability requirements. Workability requirements. For more workability, we should not increase water. This should not be done. So these are the three major problems, and these are only the problems which it got lead to something addition to the mixture, something agent we need require, we are required with one more agent to the mixture. Why? Because we cannot change the basic ingredients. Basic ingredients are nothing but fine aggregate, coarse aggregate, cement and water. We cannot change these requirements, I mean these ingredients are cannot be changed. So we need to add one more agent or admixture to the mixture, so that our requirements, our problems are easily solved. The problem is concrete is setting easily in hot weather conditions, but what I want is it should be set some more time, I mean after some more time. It should not set before the initial setting time only. It should be given that initial setting time parameter, it should satisfy that time. In cold weather conditions, concrete is taking more than the initial setting time. That is also major problem. So I don't want that concrete is setting too late, so I'm going for the admixture. Okay, what are the different type of admixture? Admixture is, first admixture is adding an agent to the mixture. Adding an additional agent to the mixture to satisfy all my practical problems. Okay, what are the different type of admixtures are available here? There are two type of admixtures. One is mineral admixture, other is chemical admixture. Okay, why these two why there are two different type of admixtures? Here mineral admixtures, are used for long term properties. If you want to modify any long term properties in the concrete, we can use the mineral admixtures used for modification of long term properties. Then what are these chemical admixtures? These chemical admixtures are used to modify fresh properties of concrete. If you want to modify any fresh properties of concrete, you can use this chemical admixture. No, I want to modify only long term requirements, long term properties, that is strength and durability. I want to achieve some more strength, additional strength. I want to achieve durability characteristics are required to my concrete. So what I going to add? So I am going to add mineral admixtures. Here I am going to add chemical admixtures used to modify fresh properties of concrete. What are long term properties? Strength, durability. I have discussed about these two terms in detail. What are fresh properties? Fresh properties of concrete. Setting time and workability. Okay. What are mineral admixtures? Fly ash, GGBS, silica fume, chemical admixtures. What are chemical admixtures? Plasticizers, super plasticizers, accelerators, retarders, air internals. Okay. Now I will discuss chemical admixtures first and later mineral admixtures. Okay. Chemical admixtures. Plasticizers. Okay. What are plasticizers? These are also called as water reducing agents or water reducers. Okay. When I am going to add these plasticizers, what is the major requirement? Why I need to add these plasticizers? So okay. Now the problem is, so workability of my concrete is very less. Okay, I mean the ease of working with concrete is very less. So here I am not going to add any additional thing, that is water. Why? Because if I am going to add the water, I am not going to follow the codal provisions, and what I am going to achieve, the strength, the durability requirements are not at all satisfied. So what I have to add is here plasticizers. So what the plasticizers are doing here, we are okay, Now we will go into detail. It is also called as water reducing agents and water reducers. So the usage of water, the addition of extra water to get modification in the properties of concrete, that is, we require the workability of concrete. So we are going to achieve it by using these plasticizers. So that's why it is known as water reducing agents or water reducers. Okay, so this what these plasticizers are doing. Okay, before adding plasticizers, all the particles, all the coarse aggregate, fine aggregate present in the concrete mixtures, they are getting closer. So due to, since they are getting closer, when the two particles, two similar or different particles, when they are in contact, so they have high friction. So we need to break the friction. Here these particles are very close in contact and they are creating and they are developing high amount of friction. So we need to reduce the friction between them. So I need, here water can also act as a lubricant, but due to addition of water we are going to, we are going to fail. So we are not following the codal provisions, so we are not getting the strength, and we are not going to get the durability requirements. So what we are going to add, we are going to add plasticizers. So what these plasticizers are going to do here, the role of plasticizer in the mixture is, it is going to break the bond between two particles. It is going to break the bond between, and it has to develop, it has to break the friction between the particles, so that all particles can slide over the other and workability is easily increased without any addition of water. So that's the thing. So before addition of, here before addition of plasticizer, okay, now I have added plasticizer to the mixture. What is happening, the friction between the particles has been deleted, it has been completely gone. The friction between the particles is reduced. So what happens if friction is reduced between the particles, the development of friction is less. So the lubrication is possible by the addition of these plasticizers. Thereby I have reduced the water requirement. My goal, that is lubrication, it has to be achieved. So when lubrication is well achieved by using plasticizers, all particles can roll over each other and I can work with the concrete easily by without addition of water only. Okay, after addition of plasticizer, after addition of plasticizer, all particles lost its friction. Okay, here all particles are very close. So when the external load is also applied, this type of structure is also called as honeycombing. Honeycombing is can be seen in these type of structures. So in this structure large amount of settlements are also possible due to when load is applied, a huge gap is expelled from here, that is void, and it gets compressed. There are large amount of settlement here. So what happened here, after addition of plasticizers, all particles got divided, and friction is also less, lubrication is also very good, and plasticizer have solved the major problem without addition of water. So we can conclude here, plasticizers are helpful, and it is therefore it is called as water reducing agents and water reducers. How much amount of water they are reducing, and how much amount of plasticizer you are going to add to the mixture. Yes, by adding this plasticizer, I am going to reduce 10 to 20% of water requirement. What I am going to add, I mean additional amount of water, 10 to 20% of additional water required to produce the workability of the mix. 10 to 20% of water is getting reduced, and same amount of strength is achieved. Without any addition of water. Okay, 10 to 20% of water is getting reduced, and same amount of strength is achieved at the end. Okay, how much dosage of plasticizer, how much I am going to add the plasticizer dosage. So it is basically 1 to 2% by weight of cement. This has been limited by IS code IS 456 2000. So the dosage of plasticizer is also limited. How much it is limited? How much you are going to add to achieve the same amount of, I mean 10 to 20% reduction of water by adding only 1 to 2% by weight of cement. Yes. Now the other super plasticizers. These are called as high range water reducers. Okay, what are the plasticizers available actually? What are the basic plasticizers available in the market? Sulfonic acid, polyglycol esters, hydroxycarboxylic acid. These are the basic plasticizers available in market. Okay, super plasticizers, high range water reducers. These are called as high range water reducers or high range water high range water reducing agents. Okay, process. It is also similar. similar to plasticizers. These are also doing the same process. What they are doing, they are breaking the friction between the particles, and due to the due to breaking down of the friction between the particles can slide over each other, thereby the workability requirements are achieved, and thereafter the strength durability characteristics as per the codal provisions it is achieved. Okay, so when we have to use super plasticizers, if we want to reduce more than 20%, more than 20% water usage, there we can go with super plasticizers. If you want to reduce only 10 to 20% of additional requirement of water, we can use plasticizers easily. If you want to reduce more than 20% of the water, there we can go with super plasticizers. What are super plasticizers? Modified lignosulfonic acid, SMF, and SNF. Dosage. The dosage of super plasticizers is also limited to 2%. 2% of 2% by weight of cement. Okay. Dosage of plasticizer, super plasticizer is 2%. It is given by IS 456-2000. Now I am going to discuss about retarders. Okay. What is the purpose of using retarder? Okay, if I retarder are nothing but these can be used when I want to increase the setting time of concrete. I want to delay the setting time of concrete. So the setting time of concrete or cement is actually fixed. So initial setting time should not be less than 30 minutes, and final setting time it is limited to 10 hours. I mean, final setting of concrete will be done. I mean, the it after it it will be reaching to its hardened state within the 10 hours. Okay, so what is the purpose of using retarders? The purpose of using retarders is to delay the setting time, of concrete. If my construction site is I cannot travel the construction site within the 30 minutes, so I want to increase the setting time of concrete. I want to increase the initial setting time of the concrete, so I am going to use retarders. I will delay the setting time of the concrete. There I can use retarders to delay the setting time of concrete. I am going to use retarders. So what are the retarders are available in the market? Gypsum, sugar, plasticizers, super plasticizers. Yes, plasticizers and super plasticizers can also act as retarder in the concrete. So indirectly, if you are adding plasticizers and super plasticizers, indirectly we are delaying the setting time of concrete. So here, if you are delaying the setting time of concrete, we can have the same amount of workability what we have with the initial, how we are having with the concrete. So yes, these are the gypsum, sugar, plasticizers, super plasticizers. So what is the dosage? What is the dosage of retarders? 0.5 percentage of 0. percentage by weight of cement. You cannot use as much as you like. Code has specified some requirements and we need to follow that. IS 456-2000, it has specified the usage of retarders. It can be only 0.5% by weight of cement. So where I want to delay the setting time of concrete in hot weather conditions. I have stated the problem initially only. Hot weather climatic conditions. In hot weather climatic conditions, concrete will be going to its hardened state easily. So I want to delay the setting time of concrete. I want to work there. I want to work with concrete in hot weather climatic conditions. So how the problem will be solved? So I'm going to add retarder there. So thereby the delaying the setting time of concrete and I can work efficiently. Accelerator. I want to speed up the setting time process. Setting time process of concrete. So there I am going to use the accelerator. Here we can say to reduce setting time of concrete. Okay. If I am working in cold weather conditions, where temperature is very low, there the actual setting time of concrete is delayed, but I want to work with concrete easily. I have only a limited time, so I'm going to add the lead accelerators. It helps me to reduce the setting time of concrete there. That is, concrete hardens easily. Okay. What are the basic accelerators available in the market? Calcium chloride. If I want to reduce the setting time of concrete, that is, I want to get concrete harden easily, rapidly. So I am going to add CaCl2. What is the dosage? Here dosage is also limited to 0.5 percentage. 0.5 percentage by weight of cement. Okay. Okay. We have discussed concrete properties. What are the basic concrete properties? Strength, durability, setting time, and workability. We have discussed strength in detail. Resistance to failure is known as strength. Durability, resistance to abrasion, weathering, environmental effects, and discussed the setting time also. Initial setting time, final setting time. It is limited to 30 minutes. It should not be less than 30 minutes, that is it must be greater than 30 minutes, and it is also limited to 600 minutes. Concrete must get hardened within 600 minutes. Okay. So IST I have discussed. IST is nothing but time at which concrete is losing its plasticity. FST, the time required to concrete to get into a hardened state, is nothing but finite setting time. I have discussed the usages also of the setting times, and I have discussed about workability, the ease of working with concrete when I am during mixing, placing, transporting, compacting. How is the working with concrete? Is it easy or else is it difficult? That is known as workability. We have different type of tests also to determine the workability. They are slump cone test, VB compaction factor test, and VB consistometer test, sorry, compaction factor test, and flow table test, and Kelly ball test. So based on that test also we can determine the workability. Okay, I have discussed about workability also. And then strength, durability are properties where we can achieve it in hardened state. Okay, and these setting time and workability are the properties when concrete is fresh, that is freshly mixed. These properties, if I want to modify only these properties, I want to modify freshly mixed properties, I want to modify fresh properties, there I am going to add chemical admixtures. If I am going to modify the long term properties, that is strength, durability, there I am going to add mineral admixtures. Okay, what are the mineral admixtures? What are the different type of chemical admixtures available? Yes. What are the different type of chemical admixtures? Plasticizers, superplasticizers, accelerators, retarders, and air entrainers. Here, what are mineral admixtures? Fly ash, GGBS, silica fume. Okay. So plasticizers, I have discussed the phenomena also. Superplasticizers and the dosage, accelerators, retarders. Yes. Now I am going to discuss air entraining agents. Air entrainers. What are these air entrainers and what is the usage? Here one more problem with the concrete or with the climatic factors is, and the problem with water is, it gets freezed when temperature is down. I mean, during freezing temperature, the water present in the concrete, it gets freezed, so the volume of water is increasing, so it needs some additional volume when the temperature is down. Okay, and when again temperature increasing, and it gets decreased, the volume decreases of water. Okay, here the problem is during, that is known as during freezing temperature down and thawing, how my concrete is behaving. So how I need to stop, how I need to reduce the problem with water. So what these air entrainers are doing, these air entrainers are inducing millions of air bubbles, in my concrete. Okay, millions of air bubbles in concrete. So how this is helping in my concrete? When these millions of air bubbles are present in my concrete, the water present in the mixture, so when temperature is coming down, that is during freezing temperature, water tries to occupy the additional volume. So there it tries to expand, it tries, I mean, the tensile forces are acting on water. So there, these air bubbles already occupied in the mixture, they gets breakdown, and they release the pressure present in the water. So thereby we going to achieve the problem faced due to freezing and thawing. These air bubbles will break down, these air bubbles will break the pressure developed in the water during freezing temperature, and during thawing temperature also these air bubbles going to help in the concrete mixture. So what are the different type of air entraining admixtures are there? Wood resins. Okay. Now I am going to discuss mineral admixtures. What these mineral admixtures are do? If I want to modify, they modify long-term properties of concrete. Long-term properties of concrete. They are strength and durability. Fly ash, GGBS, silica fume. Okay. Why I will add these all admixtures, these mineral admixtures into my concrete? So I am going to modify the strength property and durability properties by adding this fly ash, GGBS. GGBS is nothing but ground granulated blast furnace slag. Okay, and silica fume. So where I am going to get these all? These all are byproducts. Byproducts. Byproducts of thermal, coal, steel industries. Okay, these all are the byproducts of, byproducts are residues of thermal industry, coal industry, steel industries. Okay, so why I'm going to take these only? These properties, these fly ash, GGBS, silica fume are having some cementitious properties. They are not going to have the directly the cementitious property, but during addition of water, when you are going to add water with this silica fume or fly ash or GGBS, they are going to develop some cementitious properties. Okay, then what is the advantage? What is the advantage of using this? So here we have used cement. So concrete is a mixture of cement plus fine aggregate plus coarse aggregate plus water. Okay, if something the other material is going to have the same cementitious property, and that properties are going to we are getting from the byproduct of different large scale industries where we are producing large amount of coal, steel, and the byproducts from there, we are having cementitious properties by addition of some water. So we can reduce the usage of cement here. So by reducing the usage of cement, we can uh, take the advantages and the benefits from the byproducts of the large scale industries. Okay, so and not only the reducing cement, by using mineral admixtures, reducing cement content, reducing cement content, reducing heat, heat of hydration, heat of hydration. What is heat of hydration? During addition of water to the cement, the amount of heat it is producing, uh, when we are constructing large amount of structures, large structures, that is dams, we need to produce mass concreting, we need to prepare large amount of concrete, and we need to pump to prepare a large scale structures. At that time large amount of heat is produced. There we can use these type of mineral admixtures, and thereby reducing the amount of cement and thereby reducing the heat of hydration also. So mineral admixtures are solving the problem here, and they will increase increase strength and durability. Durability characteristics. Increase strength and durability characteristics in concrete. Okay. I have discussed about mineral admixtures and chemical admixtures. I have discussed about fly ash, GGBS, silica fume. These all are byproducts from different large scale industries. They are thermal, coal, and steel industries. And here, silica fume is the finest finest particle finest particles among all these. It is literally 100 times smaller than fly ash. So what is the use if it is finest particle? If it is finest particle, the surface area, I mean the specific surface area is more, the coverage is more, the bonding is more. It will surround the particle effectively. It will bind the particle effectively. So if it is binding effectively, the amount of, I mean the binding nature, the hydration is easy, and thereby heat of hydration is reduced. Here I want to discuss a little bit. Okay, since there are existing siliceous properties, so what is happening with this? Okay, so for strength requirement, we are talking about strength. So how strength is achieved? This is due to the formation of CSH gel. This is nothing but calcium silica hydrate gel. If you are adding water to the concrete to after completion of structure, the purpose of curing is also similar. It comes under the same line, that is the formation of CSH gel. How much amount of gel is prepared when you are hydrating the concrete structure? If you are if you are spraying water continuously to the structure, how much amount of CSH gel is preparing? If it is directly proportional to, if CSH gel is more, strength is more. So our ultimate target is CSH gel. How it is going to prepare? So if CSH gel is more, the strength of concrete is more. Yes, here I can conclude the topic of admixtures. Thank you.